Hello everyone, I'm Rinku Dhiman, working as an assistant professor in electrical engineering department at RPIIT Technical and Medical Campus Karnal. So today I'm here going to discuss with another topic, power system protection. So power system protection including number of equipments and one of the important equipment is fuses. So fuses is a protection device which is generally utilized in every electronic circuits. Either start from television to other power system electronic devices as well. So here we'll discuss about the basic construction of fuses, its advantages, disadvantages, and its time dependent characteristics as well. So first of all, we will talk about the introduction. Fuse basically was patented by the Thomas Edison in 1890. Fuse is the simplest and cheapest device that used for interrupting an electronic circuit under short circuit of or excessive of currents. So the fuse element is generally made of material having low melting points, high conductivity, and at least deterioration due to oxidation, and like silver, copper, etc. So these are the basic configurations, or we can say that structured fuses that is given over here. This one, and this one. So these are the general type of fuses we always use in home appliances or in a home electric metering system as well, for the protection of our electric system. And these are the protection basically used in smart power electronic devices as well. And the another type of protection type fuse construction is this one. If we'll talk about the advantages and disadvantages, the first of all advantages, it is the cheapest form of the protection available. It requires no maintenance. Its operation is innately completely automatic, unlike a circuit breaker which requires an electronic equipment for automatic action. So in circuit breaker we need a relay which gives us sensing signals that fault is occurred, so the circuit breaker contacts open up. But here the working of the fuses is not like that. Once he get the overcurrent or short circuit fault over there, fuse will get blowout. We will talk about the next. It can break heavy short circuit current without noise or smoke. Then if we'll talk about the disadvantages, the first one is it require a considerable time, or we can say that the lot of time is lost in rewiring or replacing a fuse after operation, right? And the second thing is that on heavy short circuit, discrimination between fuses in series cannot be obtained unless certain sufficient difference in sizes of the fuse is concerned. So in heavy short circuit fault, the discrimination between fuses and series cannot be obtained unless we are getting the sufficient difference between the sizes of fuses. And the third one is that the current time characteristic of a fuse cannot always be correlated with the with that of protected operators. So the current time characteristic we can't do relate every time with the same equipment that will totally match up with each other. So here the fuse time current characteristic is given, like we can say that y-axis define the time and x-axis is define the protective short circuit current. So if you can see that the time required to blow out the fuse depend upon the magnitude of excessive current. So this is the current limit, we can say that. So greater the current, smaller the time taken by the fuse to blow out. So say we can say that here is the maximum current and here the minimum time is required to blow out the fuses, whereas we can see that the current over here is less and the time taken for this is very high. So totally depend upon the time current characteristic is totally depend how rapidly the short circuit current is built up. The time taken will be very high for the small value of current, and when the current is very high, the time taken is very less to blow out. If we'll talk about the material for the fuse element construction, so the first thing is that the characteristics of material is that it is completely free from oxidations and it does not deteriorate when used in the dry air. So these environmental condition we have to consider. The third point is that the coefficient of expansion of silver is so small that no critical fatigue occurs. So we can say that fuse element can carry the rated current continuously for a long time. As we know that the conductivity of silver is very high, so we can say that a given rating of fuse element or the mass silver metal required is smaller than that of the other materials, and we can say this minimize the problem of clearance the mass vaporized material set free on fusions that permits the fast operating speed. And due to comparatively low specific heat, silver fusible elements can be raised from a normal temperature to vaporization quickly, and then other fusible materials. And also we can say that moreover resistance of silver increase abruptly as the melting temperature is reached, so that making the transition from melting to vaporization almost instantaneous. So operation become very much faster at a higher current. When silver vaporizer at a temperature much is lower than that one of the vapor will rapidly ionize, and we can say that when there will be arc performed through the vaporized portion of the element, the arc path has a high resistance. So as a result of that, short circuit current is quickly interrupted. So we can conclude it over here like the fuse material best one is the silver, which have a high conductivity. So during the high current, that conductivity take place, and it have a very high deteriorating capacity in case of dry air, and it is free from oxidation as well. So it is a very good fusible material. So silver is always used as a construction of our fuses. Thank you very much. This is all about the fuse production introduction. Please stay tuned with us for more videos on protection devices like fuses. Thank you.